Okay, I'm going to talk about my Royal Enfield distributor. There's some argument as to whether or not it should be called a distributor. Let's just say Royal Enfield call this a distributor. This is off an earlier model Indian Royal Enfield Bullet. So this is the type which has bronze bushes rather than bearings inside. I actually want to dismantle it because there's an enormous amount of play in this, which is potentially causing me some problems with the bike running. I'll point out from the get-go that I've modified this because the tapped holes that normally hold the points plate on, the contact breaker plate, stripped out very early in this bike's life. My solution to that was to insert some M6 bolts with a flat on them through a hole, and then use nuts to hold the plate down. So these aren't standard. You would normally have a threaded bolt that holds this to the aluminium casting, but this seemed a reasonable solution. So this is on the left side of the bike, underneath the distributor cover, and this is on the right side of the bike, which is located inside the timing housing. So this is the bit the engine turns, and then the points are on this side. Yeah, I'll have a look at the points first. So you can see in there we have the contact breaker points and the cam and the condenser, and when that's turned, the cam, bolted down right, when that's turned it causes the points to open. Okay, the way this is bolted down, this cam can rotate partly on its shaft, and that gives us the automatic ignition advance retard, which I'll show you in a bit. First off, I'm going to remove the contact breaker backing plate. I've already dismantled all this, as you can see, because it's off the bike. So on a standard one, you would just undo your two bolts, which look somewhat like this, are long bolts, but they have a threaded section, a male threaded section sticking out at the end. I say this is slightly different because I have already knackered the threads in that hole. So that just lifts off, and it would connect into the wiring room with a single wire. I'll put that to one side. Now you can see the ignition advance weights. So these are bob weights. So as this rotates in use, when it reaches a certain speed, the centripetal force forces these weights to move out, which then causes the points cam to rotate slightly. So it goes from it's supposed to go from 10 degrees to 32 degrees. One thing I'll show you is when you're setting the timing. I'll take this centre bolt out. It's far easier to set the timing with the points in the fully advanced position. So this is the retarded position, and this is the fully advanced position. So if you can lock that cam in that position, it's much easier to set the points at 8mm before top dead centre, rather than in this position, which is 0.8mm before top dead centre. You tend to find that the crank rocks backwards and forwards over top dead centre, whereas if you're doing it at that 8mm position, it's just easier to put the cam in that place, to put the crank in that position and set the timing there. So for that purpose, Hitchcock's motorcycles make a small dished washer, which you put with the dished side down on top of that, so that when that bolt's tightened down, the washer will bear against the cam, and prevent it moving. As standard, it has a small diameter washer which only bears against this inner portion, so the cam remains free to rotate. So if I put the dishwasher with the concave side facing the cam, tighten it almost all the way down, what I can do is rotate that to the fully open position, then tighten this down on top of it, and you'll see that then locks those weights in the fully advanced position. And hopefully you'll be able to see, if I loosen this, they move back to the fully retarded position. Okay, so enough of that. What we want to do next is take this advanced retard mechanism off, and for that there is a special tool, and this screw, it's an extractor tool, and this screws into the end. Check you can see, yes. So we screw this into the end, and the whole assembly is just mounted on a taper, so once it's tightened fully it will pop this off the taper. So you can see there's a taper which goes inside this hole. Again, we'll put that to one side. Now I've got this whole piece removed from the bike, so normally the timing chest would be here, so this sits into a hole in the timing chest, and it's held in by these 3 bolts, and it has a drive pinion over the top of it. There's another taper on this end of the shaft, and obviously in order to get these bolts out we need to remove this pinion. So again, this is all been removed previously. We need to undo this nut in the middle, and then I have found that a modified 2-leg puller will just and only just fit in. So you can manage to wiggle it in here so that the puller is sat beneath that pinion. There is a proper tool for this job, but I had a 2-leg puller, so that works, and you can get that in there, and then by tightening it, it will pop this off the taper. So you can see that's just a hole and then a taper on the end of the shaft. I'll just get to the reason why I'm doing this. If I tighten this back up again, just so it's at least gripping, it's not going to be fully home, but it'll be tight enough to demonstrate what we're meaning. There's an enormous amount of play on this, horizontal play, so I can move this a significant distance. Now I measured how much play there was using a vernier just to measure this gap with it pressed one way and then pressed the other. So with everything tightly assembled, I was getting 3.3 millimeters of horizontal play, which is quite ridiculous really. So my aim for today is to remove that play from the system. In order to do that, I need to remove the distributor shaft. So yeah, we have removed the nut, we've pulled the pinion, and we can now push the shaft all the way out. Now in order to do this, you don't necessarily need to remove the distributor casing from the bike, but if you want to do that, you can now get at the end of these bolts, undo these 3 bolts, and this whole casting will just pop off the crankcase. There is a paper gasket in here, which will need to be replaced when you replace the housing back on the bike. The reason you might want to take this off is if there is horizontal play in the bushings. If you look in here, you can see there's a bronze bush there, and on this side there's an oil seal, and then there's a second bronze bush. So you can get a punch down through here onto the lip of the bearing, and you can gently tap these bearings out of the casing one at a time, and they will pop out. You may be able to see the lip of that one, the lower bearing there. So you can tap these out. They're made of phosphor bronze. These ones aren't bad. They're there's no appreciable sideways play on these, so they're good. I'll mention there is a bodge for reducing this play that I'm trying to do now, which is to tap this bushing away from its seat so it's protruding slightly. Then when you tighten everything up, it binds against that bushing, and once you've got it all assembled, you give a very light tap on the end of the pinion, which will seat the bushing slightly and take a lot of that play out. What I want to do today is reassemble that with some shims.